following is a production of the Computer Information Systems Department at the Metropolitan State University of Denver. Welcome. In this short video, we will explore the following questions. What is a database? What is a database architecture? At their core, databases are ways of storing data. Since we're just starting out, it might be convenient to think of data as a series of columns and rows. You've almost surely seen data presented in this format in Excel, and hopefully you've also seen data in the rows and columns format in Microsoft Access. Again, for now, let's just say that a database stores data. Early databases were file-based, but starting in the 1970s, most databases started using a relational design, which we will go into later in the course. Databases rarely stand alone. In fact, they are rather useless without what is commonly called a database management system, or DBMS for short. You can think of the relationship between the database and the database management system as the database being at the bottom, with the DBMS sitting on top of the database. In this analogy, the database is the foundation, with other parts of the system built on top of it. At this point, I'd like to point out that another term for referring to the design of an information system is to refer to the system's architecture. In the context of this video, we use the terms design and architecture interchangeably. So if I say I'm an information systems architect, I really mean I design information systems. It is also common to refer to a system architecture, in which we mean the design of the information system. Back to the database management system. The DBMS allows users, whether they be humans or computer programs, to interact with the database. In fact, there are only 4 interactions allowed by modern database management systems. Those interactions are read, insert, modify, and delete. The interactions are largely self-explanatory, but do not make the mistake of thinking they are necessarily simple. As we will see, these 4 actions can perform an infinite number of operations. A database management system sitting on top of a database is pretty much as simple as it gets. It is safe to say that this is what you get when you run Oracle or another database from the command line. However, command lines are not always intuitive and, quote, user-friendly, unquote. Consequently, another layer of the architecture was designed to make interfacing with databases easier. For the purposes of this video, we will call this layer the presentation layer. If you've heard the term graphical user interface, or GUI, that is a reference to a presentation layer. If you have ever used Microsoft Access, you've used a presentation layer. In Access, you've seen that you can present the data in a relatively easy to see and understand format. In this presentation layer, forms give us an easy way to input data. Reports give us an easy way to see the data, and queries give us an easy way to write queries of the data. Forms, queries, and reports are all examples of graphical user interfaces intended to simplify interacting with the database management system. Let's consider an example. Here we have the same query shown 2 different ways. On top, in blue, is an example of the query performed by the Access Query by Example, or Query Wizard. Below, in red, is the same query as a command line in SQL, or SQL. It is important to understand that both queries will have the same result. In fact, the top Query by Example will simply create the same SQL statement that you see at the bottom of the page. The intent is that the users do not have to write computer code. The wizard does it for us. On the top, we see the presentation layer. On the bottom, we see the database management system layer. Here is the same idea represented again as layers. In the early days, developers used specialized software packages to create queries, forms, and reports. One example of such a software package was simply called Oracle Forms. In Oracle Forms, you use software provided by Oracle, that's the big database company many of you are probably familiar with, to create little software programs called clients, which were essentially a set of forms and reports that someone created. The idea was that the company could host a database and a database management system on a server somewhere, and then install the client programs on as many desktop computers as they wanted. As long as a computer had the client software program installed, the client could call the database and interact with it. Hopefully it's obvious why this client-server design or architecture was a huge step forward in computing. In the old days, you used to need a computer science degree and lots of training to interact with a database. If a manager wanted information, he had to ask someone trained in the use of databases to get the data for him. One huge change wrought by the client-server architecture was that people who didn't know how to program databases could now interact with them in a relatively simple manner through forms, reports, and wizards. The time required to train someone to interface with a well-designed graphical user interface could be cut to just minutes or a couple of hours, whereas teaching people to interact directly with the database management system through a command line almost always took several days or even weeks. Keep in mind, of course, that since less skill and experience were required to interact with the forms and reports than with the database management system command line interface, computer users could be paid much less than a true computer geek. So not only were things being done faster and more efficiently, the people doing the work could be paid much less. As a quick example, let's consider a manufacturing company. In 1980, this company probably paid a workforce to take inbound calls from clients who wanted to order products. Orders were probably taken on a paper template, and the whole order was tracked via paper. By 1990, there's a good chance that the paper template had been replaced by a desktop client. The sales force took the order over the phone, input the order into a form that was made available via the desktop client, and the entry was immediately entered into the main database, where other sales reps could access it, say to increase or decrease the quantity of items ordered. In addition, people in the warehouse now had easy access to the order information, and accounting knew exactly how many orders had been placed in a given day, week, or even hour. Stop for a minute and truly consider, what were the advantages of replacing paper with an electronic form? As you might guess, clever students that you are, many companies decided that instead of providing forms to their sales force, they could just provide forms directly to customers, essentially eliminating the need for employees who had previously been taking the orders. Although the move from paper templates to client-server forms was a massive improvement, there were still problems. For example, if the company wanted to make changes to the form, it's safe to call this change an update, every computer that used the client had to have the new client installed. Since there was almost never a list of all the computers which had the client installed, the updates were willy-nilly and haphazard, which wasn't what you wanted, especially if you were fixing a security glitch in the system. This willy-nilly upgrade strategy might leave you with 80% of your users using the corrected version of the client and 20% using the old version of the client, with the old version still making errors or being insecure. However, even with the errors, pretty much everybody agreed that the client-server computer systems were far better than the old paper template methods of the Dark Ages. Then, in the mid to late 1990s, the web exploded onto the scene. The web is still, at its root, a client-server architecture. The client, in this case, is just your web browser. For example, Internet Explorer, Chrome, Firefox, Safari, etc. Each company hosts its server, and the client uses a URL, that's the thing at the top of your browser that says www.heybuddy.com or whatever, to find the server it wants. Now the server can serve up the website content, which might just be a list of sports scores or tomorrow's weather, but a more sophisticated website can allow users to input data into text boxes or even as entire files. The bottom line is relatively simple. Instead of having to develop and distribute specialized clients for every form and report we wanted our users to use, the web browser acts like a kind of generic or universal client, and we can just serve up our form or report as content within this generic client. Want to update your form? No problem. You don't need to redistribute your client. Just update the content on the server, and the next time your user accesses your website, they will get the new version of the form without doing a thing, and in most cases, They'll never notice that a difference was made. Okay, but what does this mean for me, I hear you scream? Well, the upshot is that today almost all web pages really are either forms or reports. When you go to Amazon.com and look for a watch, the results page acts as a report, telling you the results of your database query. So I know what you're saying to yourself. Do you mean to tell me that, in effect, I'm already using databases anytime I use the web? Whenever I check my email or the weather or Facebook, I'm actually using a database? Yes, that's exactly what I'm saying. The web browser, which is a client, acts as a form to collect the information you want to query. Knowing this, I can now explain what we're doing in this class. This class is intended to give you a very basic introduction to each layer of the database architecture. We will start by examining databases. What do they do? How do they work? How do they store data? We will next move on to the database management system. Basically, how do you perform reads, inserts, updates, and delete? Next, we'll look at basic database design and management. How are databases designed? What is a good database design versus a bad one? Next, we'll look at basic database administration, essentially the proper care and feeding of a database, including security. Finally, we'll wrap up the course with an exploration of how data can be turned into knowledge. To do this, we'll explore the R statistics suite. So for now, let's just do a quick review. Databases are used to store data. A database management system is used to interact with the database. The database management system can do 4 basic functions: read, insert, update, and modify. These 4 functions can be combined and tweaked to perform an infinite number of tasks. A database management system is all that is required to interact with the database. However, a presentation layer, or graphical user interface, often sits on top of the database management system. This layer is intended to make it easier and faster to interact with the database management system. Forms are graphical user interfaces that allow users to input data into the database. Reports are graphical user interfaces that show us what's in the database. Often we use forms to tell the database what to show us, and reports are then used to show the data we've requested. In the old days, client programs were written to present forms and reports to users. The clients had to be installed on every computer that wanted to use them. When the web came along, our web browser acted as the client, and the web server could tell the client what form or report to show. A key idea here is that web browsers now act as forms and reports for databases. Using the web today is almost always an interaction with the database via a form or report that is being presented in a web format. In this class, we start by studying databases, then the database management system, then database design, then the care and feeding of databases, and finally we'll apply our ability to start with basic data and turn it into knowledge. I hope this video was helpful. Please email me if you have questions or comments. Thanks for watching.